Water is one of the most precious resources on Earth, and the water used for irrigation in agriculture is very important, as irrigated agriculture provides for 40% of the food worldwide, while requiring only 20% of the land. Getting to know what will be the needs for water withdrawals in agriculture is then very important for managing this precious resource around the world. How can we come up with these predictions? There are two main ways that are done in the world. One is by the Food and Agriculture Organization that uses surveys, data collection, report for countries. While this is an effective way in principle, unfortunately the data are often not homogeneous and not reliable. On the other side, we can rely on complex scientific models like global hydrological models or surface land models that take into account several characteristics, physical characteristics of the problem, like the time of the year where we are, the nature of the soil, evapotranspiration, and several other, the property of the crops, so several other types of factors that go into this complex problem. However, these models are sometimes long to run, and they are good for small scales, but when you sum them on global scales, they may lead to unreliable predictions. We discovered in this analysis done with Arnald Puy at Princeton University, Samuele Lo Piano at Reading University, Simon Levin at Princeton, and Andrea Saltelli at the University of Catalunya, we found out that there is one key driver for the predictions, which is the size of the irrigated region. Thus, if one focuses on this factor to get a model and data, one gets better predictions than focusing on several of the other factors. This result is on the one side surprising because there are several other factors that affect the problem, but it happens in nature that sometimes one of these factors is a key driver. And on the other side, it leads to a solution in the sense that we can get faster models that predict better, and we can get more information about the uncertainty drivers and the key drivers, thus contributing to have better predictions for water irrigation in the future.